Hey everybody, in this video we're going to learn how to properly name with correct nomenclature acids and bases. If you're in my class, then you have a flowchart to help you inside your acids and bases notes in the packet, but if not, it's also here listed separately, naming acids and bases flowchart. Okay? And then you have an assignment for naming acids and bases. So the flowchart looks like this. It's pretty simple. Naming acids are slightly different than some of the other things we've named so far. Naming acids, what you do is you look at the ending of the anion, the negative ion that's in the acid, and you change the ending based on what it was originally. For example, if the anion originally ended in "ide", then you're going to change the you're going to add hydro to the front, replace "ide" with "ic", and then add acid at the end. For example, HCl ionizes H plus and Cl minus. Cl minus is chloride. Okay, so you put a hydro on the front, hydrochlor, and then the "ide" becomes "ic". So hydrochloric acid. So HCl is hydrochloric acid. If the ending of the anion is "ate", one of the polyatomic ions like sulfate or nitrate, then you replace "ate" with "ic" and add acid. No hydro prefix. Okay, so an example of that would be HC2H3O2 ionizes into H plus and C2H3O2 minus. That's acetate, and so the "ate" becomes "ic", so it's acetic acid. Acetic acid. Or like if you had nitrate, HNO3 would be nitric acid. If you have a polyatomic ion that ends with "ite", okay, so "ite", you replace "ite" with OUS and add acid, no hydro prefix. For example, HNO2 nitrite becomes nitrous acid, okay? Basically, if you have an anion that is coming off of your periodic table, those all end with "ide", like chloride, bromide, fluoride. If you've got an ion coming off your periodic table, that is when you are going to have it say hydro whatever ic acid. So like HBr would be hydrobromic acid. Okay, so let's do a couple examples. I'm going to keep the flowchart up just in case. So here's some examples. HCl. Cl is chloride, so if it's ending with "ide", you add the hydro prefix, so hydro, chlor, and then the "ide" becomes "ic", so hydrochloric acid is what HCl is. Okay. For bases, bases are really simple. For most common bases, you just use the name of whatever the cation is, the positive ion, followed by hydroxide for the OH. For example, NaOH is just sodium hydroxide. Nothing too complicated about base naming. Alright, HNO3. That is H, and NO3 minus is nitrate, if I look at my polyatomic ion chart. So 8, if you look at the flow chart, 8, replace 8 with "ic", so nitrate becomes nitric acid. Alright, we got another base. We got aluminum and hydroxide, so it's literally just aluminum hydroxide. Okay. Okay. H2Se. Se by itself is selenide. So selenide is from the periodic table. So that one is going to be hydro, because it ended with "ide". Hydro selen, instead of "ide", we change "ide" to "ic". Hydroselenic acid. Okay. Another base one, NH4OH. NH4 is a polyatomic ion. That guy is ammonium. And OH once again is hydroxide. Alright, H2C2O4, that's going to break up into H plus and C2O4 minus 2. C2O4 minus 2 is a polyatomic ion called oxalate. So, it would have been oxalate. So 8, based on the flowchart, becomes ic. So oxalic acid. Okay. Okay, HClO2 breaks up into H plus and ClO2, which is chlorite. So this is going to be, so we look at ite, replace ite with us. So this is going to be chlor, instead of chloric, chlorus acid. Okay? There are a few exceptions to this flowchart rule, which are slightly annoying, but you'll start to remember them pretty quick. Any acids using sulfur or phosphorus, for some reason, break the rule a little bit. Instead of being H2SO4, since SO4 is sulfate, technically that should be sulfic acid, but for some reason it keeps the entire word. So instead of sulfic acid, it's sulfuric acid. And then the same thing with phosphorus. H3PO3 is phosphorus acid, even though PO3 minus 3 is phosphite, so the ite should change to us, so it should be phosphus acid, but for some reason it's phosphorus acid. They keep their whole name and then they add the other stuff on. So those ones are a little bit tricky and annoying. So for example, if you had H2S, then S is sulfur by itself, sulfide. Okay, so this would be hydro, because it came from the periodic table, sulfuric. So instead of sulfic, it's sulfuric acid. Okay? Now your acid-base naming assignment is pretty straightforward. It just asks you to identify if it's an acid or base. So if it's got an H in the front, it's an acid. If it's got no H in the back, it's a base. And then name, as I've showed you here. Alright. Guys, have a good day.